Hey folks, this is Captain Jones here to talk to you about the character count program. So this is kind of a culminating exercise for chapter 5 that demonstrates a lot of the instructions we've learned in this chapter. Our goals for today are going to be to trace that program. It's kind of a medium length. It's one of the longer programs we've seen so far. So it's got 18 lines of code and 7 different instructions, and hopefully by the end of this you'll get some experience walking through kind of a medium length program. Along the way, this program's got a couple of interesting features in it. So hopefully you'll learn how we're able to subtract two numbers, not just a literal number, which we already know how to do, but how to subtract two registers, how to test two numbers or two registers for equality and execute different branches of code based on the result. And I'll also show you how the code is able to get an ASCII or English character from a user and print one to the display. So let's get started. We're in section 5.5 here, talking about this program, and so what we're going to do here, this is kind of the flow chart, but the idea is that we are going to have some type of file or sentence somewhere in memory. We are going to prompt the user for some character, and then this program will inform the user how many times that character appears in the file or the sentence. So, for example, let's say my sentence was something like Sphinx of Black Quartz, judge my vow, which, by the way, is the way cooler way to have a sentence with every character in the English alphabet, way cooler than black dogs and red foxes jumping over each other. So if this sentence were in memory, and the user were to type in the character A, lowercase a, then if this program works correctly, it's going to return the value 2 because there are two lowercase a's in the sentence Sphinx of Black Quartz, judge my vow. Okay, so that's what our program's trying to do. The kind of the other key to understanding this, the book talks about it in this paragraph here, is what each of our registers are doing. Okay, so I'm going to try to sketch that out here. So this program uses 4 registers: R0, R1, R2, and R3. And what it tells us is that R0 here is going to store the character that we're trying to match. So if I, like before, if I said I was trying to see how many lowercase a's were in my sentence, R0 has that value, that ASCII value. R1 is going to be used to store whatever is the current character that we're looking at. So if Sphinx of Black Quartz, judge my vow, were our sentence, the very first character we grabbed would be this capital S. And as we sort of move through the file or move through the sentence that's stored in memory, then R1 gets set to each sort of subsequent character in turn. R2 is going to hold our count of how many times the character in R0 has been seen. So it's going to start off at 0, and then if this program works correctly, it'll finish with the value 2. And then lastly, R3 is going to store the address or the starting address of our sentence or file in memory. So this is going to be something like hex 4014. Maybe that's the place in memory where our file has started. So that's going to be the value that's stored in R3. And so I'm going to try to zoom out a little bit here. If we look at this flow chart, hopefully I won't zoom out too far. The first thing that our program needs to do is sort of set things up. We need to initialize a bunch of stuff. So that involves making sure R2, our count variable, starts off at 0. We're going to make sure that the R3 has the proper address. We're going to assume that the starting address of our file is located here at 3012. And so if our sentence were located starting at memory address 4014, then that would be the value here. We want to get that value out of memory and store it in R3. So R3's got that starting value. We're going to get a character from the user. They're going to type something in the keyboard for us to match, and that's what's going to go in R0. And I'll note here that we to do that, we sort of introduce or start to sort of tease our next or another one of our trap instructions. So here, trap 25 was our halt program. Trap 23 is the instruction that we would issue to get a character from the user. And then lastly, we're going to start by putting the very first character into R1. So we're going to treat R3 like a memory address here. that points to the start of that file. We're going to get the value at that memory address. We're going to get the very first character in our file or in our sentence, and we're going to load that into R1. And you know, if our sentence, whereas like I had before, capital S would be in R1 right at the end of this, you know, sort of initialization phase. And then the to sort of the meat of the program then involves checking, okay, is R1 equal to EOT, which we'll learn in Unit 2 a little bit about ASCII. EOT literally stands for end of transmission. So it has the numeric value 4. And we're going to assume is that the our sentence or our file or whatever, that's in memory. The EOT character, or a numeric value 4, is the sort of marker that we've reached the end of our file or the end of our string. So if R1 does equal EOT, then that's the value. You know, we grabbed that in memory, then we're finished checking our file, and we'll sort of terminate our program. But as long as R1 is not equal to the end of terminal character, then we ask ourselves, okay, is there a match? Does the value in R1, the character we're looking at, match the value or the character the user entered, which is stored in R0? If there is a match, we're going to increment our count. So R2 gets incremented by 1. And regardless, if there's not, we skip that part and we move on to the next character in our file. That involves adding 1 to the address of the sort of spot in the file we're looking at, and getting that value out of memory. And so the text calls R3 refers to this as sort of like a pointer, because it points to the spot in memory that we're kind of checking one after the other. So if the start of the address was 4014, by the time we got to here for the first time, 4014 would become 4015. That would point to the next character in our string, and R1 would get whatever value is at that location. And then so this will repeat until you know, the end of terminal character is reached. Once it is, then we prepare our output. So that involves converting the decimal value in R2 to an ASCII value. And this is the process of doing that. Don't worry if it doesn't make sense now. When you get to Unit 2, make sure you do the strings lesson. That'll kind of reiterate what's going on here. But we had to prepare our output basically, and then we want to send that number to our user. So this depicts now our kind of our third trap instruction, trap 21, which effectively takes a value and gives it to the user, takes a character and gives it to the user. And again, we'll talk more about the trap instructions in Unit 2. The last instruction in our program is trap 25, the halt instruction. And so then if we scroll down here, we can see that program. Believe it or not, for all its complexity, you know, all it takes is 18 instructions here in the LC3 to do that. And so hopefully, you know, some of this is, you can already kind of start to see the features of this program, right? So, you know, up at the top, we're initializing our variables. R2 is getting cleared. R3 is getting the, you know, whatever value is stored here, which is the first address or the starting address of our file. All the way down at the bottom, you can see our last 2 instructions. Trap 21, put the value out, you know, to the user. Trap 25, halt the program. So what I would encourage you to do is to kind of, you know, go through line by line really, and make sure that this program makes sense. That not only does you know, is this program here a faithful implementation of that flowchart, but that it does what it's supposed to do, which is count the characters in a string. The last 2 things I want to make note of is that twice in our program we have to check. We want to check 2 things for equality. Here we're sort of checking, okay, does R1, does it equal the end of terminal character? Down here, does it match R0? So you'll see in the program, if you take a look at it, a really neat way to do this in computer science. Comparing 2 values, the way we do that effectively is to take something like A, subtract B, and if the result is equal to 0, then it you know, follows that A and B have the same value, and therefore are equal, right? And mathematically, we could rearrange this for that to be true. But you'll see that when we're effectively comparing 2 values, the way to do that is to subtract one from the other, and then test if the result is 0. The last thing I want to make note of is just this last value here, so you don't get confused. ASCII template. This is just the value that here we're sort of adding to R2 in order to convert something into an ASCII character. Don't worry about that too much. Although if you're really curious, by all means, you're welcome to read a little bit about ASCII, or even jump into Unit 2 and read that strings lesson to see what that's doing. Okay, that's all I got. I would encourage you to work through this and make sure it makes sense. And good luck on the mastery check. I'll see you all next time.